2014 polar FRQ. We're again given some graphs. You can see that this is a real consistent piece. We've got two graphs this time that are only graphed from 0 to pi. So it's really why we only have what looks like half of a graph. So we've got a circle, or should I say a half circle for r equals 3. That's going to be this part here. And then we've got this other interesting looking graph that represents 3 minus 2 sine of 2 theta. It says let R be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine of 2 theta. Find the area of R. So for this, I think there's not really any symmetry that happens here, but when I look at it, what I think to do is I say, well, this is part of R, and this region right here is really a quarter of a circle. So I can just use my area formula for a circle for that. So our area of R would, for this part, is the first part we do, we'd have 1/4 times pi r squared, which would be 3 squared. And that's going to give us the part in red there. The part in blue, all of this is defined by this other function. So what's going to be necessary for us is to define this theta value and this theta value. There are no shortcuts for this because it's not a nice geometric shape. So if we go to the graph, and I happen to bring the graph up, I'm going to hit trace. Want to make sure that I'm on the graph of 3 minus 2 sine 2 theta. It starts at 0 here, so I'll put that in there. And then we want to just trace around until we get to that y-axis. Just to make sure we have that. And our gut would say, oh, it's at 90, but you always just want to make sure that it actually is there. So that theta value is 90. So to my quarter circle, I need to add the integral for the area, which is 1/2 times the integral from 0 to 90, 0 to pi over 2, excuse me, of 3 minus 2 sine of 2 theta squared d theta. And we'll just get the value back. It will be 9.707 or 9.708. This is a 3-point question. You get a point for the answer, a point for the circle part, and a point for the polar curve part, the 3 minus 2 sine 2 theta. Okay, moving on to question B. It says, for the curve r equals 3 minus 2 sine of 2 theta, find dx d theta at theta equals pi over 6. So this is kind of, we've seen some other questions like this on the last two problems. If we want to find dx d theta at theta equals pi over 6, we first need to find what x is equal to. And x is equal to r cosine of theta. So I've got to plug in my r equation in for the r and r cosine theta, and we get 3 minus 2 sine of 2 theta times cosine of theta. That's my equation for x. Now we want to have the calculator do the work for the dx d theta calculation. Remember, to do that, you want to be back in function mode. So I'm going to switch up my mode. Also, I'm going to be in radians because now I'm calculating, not just graphing. Function y equals, I'm going to plug in this x equation, 3 minus 2 sine of 2x times cosine of x. Now, to find the derivative at a point, I do math 8. Bring up my y sub 1. Plug in pi over 6. And we get negative 2.366. No interpretation, all we had to do was find it. This is a 2-point question. a point for this, and a point for this. So knowing this formula, x equals r cosine theta, super important. For parts A and B, this is you knowing your formulas, and you're already at a 5 points out of 9. So you're in good shape if this is all the more you get on this problem. Question C. It says the distance between the two curves changes for theta between 0 and pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta is equal to pi over 3. This question feels a little bit out of left field. It's not very consistent. So first thing, let's talk about the distance between the two curves. In the notes, the review notes, I said the distance between two curves would be the difference between. You'd actually subtract the two curves. Now if I look up on the graph, from 0 to pi over 2, you'll notice that the 3 is further out than this function. So since it's further out, I'm going to do the 3 minus that function that's closer to the origin. So our distance can be represented by the function 3 minus 2 minus 4. Oh, excuse me, wrong problem. Wrong problem. 3 minus 2 sine of 2 theta. Okay, so I'm subtracting the two functions. And if we want to simplify this, we totally can. 3 minus 3, they cancel out. The minus and negative just becomes a positive, so we get 2 sine of 2 theta. This represents our distance. So we've got this formula, distance equals 2 sine of 2 theta. And if we get this right here is a point. Now the next part of the question is tricky. It says find the rate at which the distance between the two curves is changing. Whenever we see this word rate, we should think derivative. The rate at which the distance between the two curves is changing with respect to theta. So what is this question asking for? It's asking us to find d, or the derivative of our distance, which we do, looks like kind of weird, dd, over d theta at theta equals pi over 3. And again, we have our calculators. We want to make this easy on ourselves. So we're going to plug this equation into y equals. Back to y equals. And in y2, I'm going to plug in this distance equation, which is 2 sine of 2 theta. Quit out, do math 8. Bring up y sub 2. And then we're going to plug in pi over 3. And it gives me back negative 1.99999. We can certainly write that. That would also be okay to round to negative 2. So 1 point for the equation for distance, finding the derivative using the calculator, that would be a second point for this problem. So we're at 7 points from our first 3 questions. We have 2 more points to get in this last part. Question D. This one. Totally, like we're not prepared for this one based on our polar FRQ review. This one's very different. It says a particle is moving along the curve r equals 3 minus 2 sine 2 theta so that d theta dt equals 3 for all times t greater than or equal to 0. Find the value of dr dt at theta equals pi over 6. So we're looking for dr dt at theta equals pi over 6. The tricky thing here is, what is dr dt? Everything we've done here has been in terms of theta. And they haven't given us a value for, or how theta connects to t. So what we have to do is we have to think about using implicit differentiation. This is when a lot of you are going to be like, oh my god, I'm out. I'm not doing any more of this problem. But the reason we need implicit differentiation is because the t we have here is different than the theta that we actually need to be able to plug in. So, I need to think about what dr dt is actually equal to. And a clue that I can use here is that they give us d theta dt. This is what's going to connect our theta and our t together. So dr dt would be equal to dr d theta times d theta dt. So it's the derivative of r with respect to theta, but then this is the implicit differentiation piece right here. So that means that dr dt will always be equal to dr d theta, and then we know that d theta dt is equal to 3. We have the value for dr d theta. Actually, we don't have it, but we can find dr d theta on our calculators. Okay, so we know that this dr dt at theta equals pi over 6 will be equal to dr d theta at theta equals pi over 6 times 3. So let's see what dr d theta is at pi over 6. So we know that our r equation is, and I can actually do this in function mode, or I can go back to polar mode. So I'll just go back to polar mode if we, no, don't need to. We'll just stay here. We'll go to y equals, and I'm going to type in my r equation. And r is 3 minus 2 sine of 2 theta. Quit out, and I'm going to do math 8 x. That's in y1 at pi over 6. And this comes out to be the same thing I got as the last one, which is -2. So this comes out to be -2 times 3, which is -6. So this would be a 2-point problem that I'm guessing very few kids in the country got when they took this FRQ. Good news is the other 7 points were pretty doable.